So I have a digital watch that also has analog hands on it, which means, of course, that I never know what time it is. But I think it's about time. So I'll go ahead and start. Welcome to this session. My name is Tim Bird. I'm an engineer, software engineer at Sony. I work on the Linux kernel. Also, I represent Sony in the Linux Foundation in something called the CE Workgroup. I'm the architecture group chair. And this is a talk, Status of Embedded Linux, that I give fairly frequently. And I apologize in advance if you've seen this before. But it does cover just the last year. I realized I didn't give it last year at ELC, and so hopefully it's new to some of you. And there's always new issues coming up, so it's always good to review. What I'm going to talk about today is kind of go over the kernel versions, hopefully not too much of a duplication of what Jonathan talked about this morning. But also talk about technology areas that are dear to the heart of the embedded developer. Talk about the CE Workgroup projects that we've done in the last little while. And then talk about miscellaneous stuff. And hopefully there'll be some time at the end for questions and also for corrections. I invariably get stuff wrong. There are subject matter experts on all this stuff in the room, so it's always a little daunting. And invariably, someone makes a correction to me. You know, I got several good pieces of feedback from ELC Europe when I gave this talk. I hope I got all of them into the presentation. I don't know if I did. If I missed yours, I'm very sorry. But let's talk about kernel versions. So if you look at kernel versions over the last year, you know, Linux is going at a really nice, steady pace. About between 60 and 70 days, approximately, for a kernel release. And of course, the odd man out there is the Linux 3.1, and we recognize that was because of the break-in to kernel.org and maybe a little bit of slowdown with some of the issues there. But when you think about it, consider if someone had broken into your work servers and disrupted your source code management system at work for 2 months, what that would do to your release schedule. And it's like, in contrast, the Linux kernel, development community turns out to be incredibly resilient in the face of this type of thing. It's a little bit of a slowdown, but basically just kept on chugging. And that is, it's a testament to the functionality of Git, the tools we're using, and also the community processes are able to route around damage, and I think that's pretty impressive. So Linux version 3.3 RC3 is what we're currently at, I believe. Linus has a terrible habit of updating right before I go on stage. I think 3.3 came out, what, Friday, or somewhere in there. But let's look a little bit at the past year. So in Linux version 2.6.38, one of the things that caught my eye was something called perf symbols abstraction. And this allows you to add a SymFS option when you're creating your perf.data file. And so you can, well, what the SymFS refers to a file system or a directory, really, where you keep symbols related to your perf data. So what this means is that you can now use perf to do off-box analysis. A lot of the Linux tools are not really geared for the embedded world because they don't kind of make the distinction between on-box analysis and cross analysis. And so this is a good sign that things are progressing well for embedded. We'd obviously like to see perf and the other tracing tools available for embedded use cases. In 2.6.39, we saw something called pstore. And this is similar to MTD oops or RAM oops. It's a place to store information from a dying kernel. And this is kind of related to the firmware on x86 machines. I think it's ACPI related. But it's possible to plug in some extensions to this or have it go other places as well for persistent storage. And so we're always looking at places to store our crashes so we can go look at them. Another thing that started happening in 2.6.39 was device power domains. for runtime power management. And this was just the beginning of the ARM architecture tree changes, where we started to see actually some churn in the ARM tree to deal with some of the issues that people had found. In 3.0, we saw a little feature, but kind of a welcome one, is fast symbol resolution for module loading. So it used to be that there was a binary lookup to do the linking, the name resolution for the linking for modules, and now that's a binary search. It seems like a fairly small and something that's really obvious, should have been done a long time ago, but as with a lot of things in the kernel, it was a little bit more complicated than originally anticipated. Took about a year to get in, but it's there now. The great thing about a feature like this is that it's invisible, except it's better. And so you don't have to do anything different with your modules or symbols or anything. It just works better. POSIX alarm timers. This is an interesting patch set by John Stultz that adds some functionality to the existing POSIX timers to give them functionality that was available in the Android alarm timer set. You'll see throughout my presentation a lot of references to LWN.net articles. And I'm sorry I don't have the titles, I just have the numbers, but you can go look them up. There's, as I said in the opening this morning, LWN.net has just tons and tons of great material on all these technical topics. The big kernel lock function calls were gone, and there were more architecture tree changes in 3.0. In 3.1, we saw the addition of something called a watchdog timer core. So there's a new watchdog framework that's in the kernel. There's also a new framework for handling power management domains that was added, and you can go look in the code base at that. And also, I think in 3.1, we're seeing a lot more board support packages adopting device tree or integrating device tree support, which is really good. And then in 3.2, we're getting more recent here. We saw the new pin control subsystem, and this allows control of multiple pins as named groups along with multiplexing. There's a lot of kind of complex issues. This is something that's people have taken various stabs at over the years. There's pretty good documentation in the kernel tree about this. And there's also an ELC talk. I thought I saw Linus. There he is. So go to Linus's talk on Friday and learn about the pin control subsystem. Also, in terms of power management, device DevFreak. I don't know how you pronounce that. It sounds a little weird to say DevFreak, but device frequency, which is basically dynamic voltage and frequency scaling for non-CPU devices. So individual devices on an SoC, you can control the voltage and frequency on. And with the complexity of modern SoCs, that's very welcome in terms of runtime power management. And then power management quality of service now supports per device constraints. So we're seeing a general trend from CPU power management to per device power management, which is very welcome. There's the SoCs, you can see all this integrated hardware, and there's a lot of complexity in dealing with managing the clocks, managing the voltage and frequency to individual parts of the chip, and how that can be leveraged to give you good power management. And then finally, Linux version 3.3. This is probable by the time we're at RC3 now, so this is like highly likely rather than just probable. But we saw the large FISKEEL address extensions. And Catalin Marinus gave a good talk about this at ELC Europe. And these talks from ELC are being recorded, and the ones from ELC Europe have been put online by Free Electron, so say thank you to them. Good job. So I think the work that Free Electrons has done over the years to record literally hundreds of talks now is just really valuable for the community. And all this stuff is online. You can go take a look at it. We also saw support for compressed audio. Interesting new capability. And a new charger manager subsystem. And I have to tell you, I don't exactly know what this thing's doing, but you can partially resume to pull a battery and then resuspend. So kind of a little quirky thing, but handy for keeping a system suspended longer. And then Android patches and staging. Okay, how cool is that? This is something that, okay, so the work is not done. And there was a panel at in the Android Builders Summit where we talked about this, and Greg, I don't know if Greg's here, but Greg was like, "Oh, it's in, it'll boot." And it's like, oh, "Okay, well, that's good." So, but this stuff is in staging. Okay, so please don't write a bunch of mission-critical code based on the current interfaces that are in staging. Okay, because this is likely to change as we kind of work in the community to modify this to be suitable for mainline. So you can go look at it, and that's the whole idea. That's the great thing about it being in staging, is now you can actually test stuff out, play around with the code, and if you have suggestions, by all means, bring them up. I'll talk a little bit more about the mainline project. In my opinion, there's a couple of key areas that are worth watching. There's the ARM architecture subtree refactoring, and Arden Bergman has a talk on that tomorrow if you want to hear kind of what's going on with the ARM SoC work. And device trees, there's actually a talk today. Device trees is kind of a really neat feature for allowing a single kernel to be usable on multiple SoCs. There's also, in the future, we're going to continue to see runtime PM improvements. We'll see more Android features. There's going to kind of always be churn in that area, but we'll see a lot more work being done there to move that stuff out of staging or to integrate it into the mainline kernel. One kind of smallish patch set that caught my eye, this was in September, was something, boot timing patches. Something that we had always wanted to do was just to kind of create a regular kind of canonical set of milestones during the boot process that you could use to compare systems. And those patches were submitted to LKML. I didn't see any follow-up on them, but that's something I've been meaning to kind of go back and check, because I think that would be handy. So that was a really quick rundown of the kernel versions. Let me talk about individual technology areas. So let me start with Bootup Time. So Bootup Time, I'm going to go out on a limb here and say it's not really that much of a kernel problem anymore. You know, you still have to tweak the kernel an awful lot if you're trying to get your system to boot up in a second. But it's kind of a well-understood, well-known problem area. There's lots of talks and presentations on kernel boot up time. And I don't want to discourage anyone from suggesting more talks and presentations on that. But there's a lot of good techniques that have been captured that are on the eLinux wiki. Really, the user space is the big problem area for boot up time these days. And that's true with a couple of these technology areas that I'm going to talk about. So what you see, instead of specific tweaks in the kernel being suggested for boot up time solutions, we'll still see some of those, but a lot of the features having to do with boot up time are more about overall performance. So things like speeding up the file system or handling memory more efficiently, things like that. One thing I want to point you to, if you're going to do any work in this area, there was a really good presentation at ELC Europe in 2010, and that was by Andrew Murray. And he had some great techniques for doing boot time reduction, but I thought more important than his specific techniques was the overall philosophy of the approach you have to have. So when you're working on boot up time, you're really, so Linux kind of, as you put a Linux system together, you've got this really general system. And what you're doing is you're going back into that general system and you're trying to take out all the parts that are not specific to your platform. And so it's kind of a process of re-specializing the kernel. And if you kind of have that mental framework, it's kind of more interesting when you go to tackle some of these problems. You go, okay, so what's one area of re-specialization? Well, I'm using dynamic linking. which is a generalization of the linking problem, but maybe it'd be better to statically link. And so it's that type of thing. If you put it in those terms, it gives you interesting ideas. But specific boot time technologies, so there's bootloader improvements that we've seen in the last year. So core boot on x86 is supposed to be a lot faster. There was a presentation at FOSDEM last year, really fast x86 boot. Over the last year also, we saw some U-boot ARM caching enhancements. It's a little shocking that U-boot did not have the caches turned on when it was loading your kernel. Seems like it should. So, that was something that was done this year. Snapshot boot is often used. It's kind of when you kind of hit a wall on being able to speed up your application boot up, you often turn to snapshot boot. We've used this in several Sony products. It's kind of an old topic. It's really just an unhibernate operation, but there are some key issues you have to deal with. Integrating, you have to have your firmware bring up some of the hardware so that when your kernel loads, kind of like a resume operation, things are laid out properly. And because of that, because it involves work both inside and outside of the kernel, there's not been a whole lot of stuff mainlined here. And this is one of the areas that I think would be really valuable to get some people together to talk about it. I know a lot of companies are doing some kind of version of snapshot boot, and I think it'd be worth getting together and seeing if there's some things we can generalize there to make some frameworks. But again, because it covers not just the kernel, it also covers the firmware. There's some issues there with collaborating. But there was a good presentation by Kang Dong-wook at ELC 2011 on this topic. Another area in Bootup Time is XIP. I don't know, how many people here are doing XIP? Anybody? Oh, gosh. Okay, it's lonely doing XIP. Which would explain why it was almost removed from the kernel. Version that was in the kernel was broken, and it was almost taken out. But Sony was using it, and we were using it on an out-of-tree platform, so shame on us a little bit. But that just goes to show you that you need to make sure that you are continuing to rev stuff and make sure your stuff is relevant in the upstream kernel. So features that you're relying on or using are not going away. And then the other area is file system speedups. So Self is funding some work in that area. Another thing that's been getting some attention is read ahead. For boot up time, there's some techniques. There's read ahead in Ubuntu. I did a presentation last year at ABS talking about doing read ahead with Android. And the conclusion of that presentation is that the Linux I/O scheduler kind of stinks for flash media, but I'll get to that in a minute. In terms of graphics, so OpenGL-ES is kind of the de facto standard now for embedded 3D graphics. For 2D, there's still a lot of things going on. Frame buffer is still used in some places, but it's starting to go away with larger screen sizes. Migo was using Clutter, Qt, and X, and kind of over the life of the project moved to a bunch of different things. Android had Skia. I don't know if they've moved to something new. But recently, there's been a lot of work around memory management between the kernel user space and the GPU. So Android has, now in Ice Cream Sandwich, they have this thing called DevIon. And it's a unified approach to buffer management. And it's kind of the replacement for PMEM. Mainline has something called CMA, the Contiguous Memory Allocator, and DMA Buff. And other than the names of them, and they have something to do with memory management, I don't know anything about these. But I've heard a lot of people talk about them, so they must be pretty cool. Anyway, in talking with some of the Google developers, I know that there's been discussion about how these pieces can be integrated together, and maybe features in Ion can be put into CMA and DMA Buff. And so I actually think that this is a problem that's receiving a lot of attention, and there are very smart people working on this. So I'm not too concerned about it. But that is one of the areas that's it's a pretty hot topic right now. Another thing that's kind of interesting is accelerated rendering. So you're seeing this is pretty important. The ability to use the GPU to its fullest is pretty key. Google introduced this thing called RenderScript, and they actually have on board an LLVM. I guess you'd call it a JIT, but it does runtime retargeting of some scripts that go along with an Android app to whatever capabilities the device has. And so if there's hardware acceleration, the compiler can retarget some aspects of the graphics rendering to that hardware acceleration. Otherwise, it can be done in software. So that's a pretty interesting development. And one of the reasons that LLVM kind of comes up a lot in discussions about Android graphics. So one of the big problem areas, of course, is there are still a lot of IP blocks out in the embedded space that we do not have open source for. PowerVR graphics chip or IP block is one of them. PowerVR has been adopted in a lot of chipsets, and I saw there's a closed source driver for it. There's some bits in the kernel for interfacing with that driver that were submitted by Alan Cox, but oh, is that the okay? What was? Oh, the display is what you use for getting the frame up and all that. Oh, okay. You use actually the stuff that's the 3D. Okay. So what did Alan Cox submit? Are you talking about when Alan Cox submitted, or? Oh, it was the display driver. Okay. So sorry, I totally mangled this. Okay. 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 Well, so in any event, this is the GPU driver for PowerVR. There's not an open source version that I'm aware of. There was a kind of a project that started last year. I saw a link on a website somewhere, but I haven't seen any progress made by anyone. This is something it would be nice to have, and as Jonathan said this morning, we'll kind of continue to see pressure on either replacements for this or ways to open this up. In terms of multimedia, we see GStreamer used in a lot of places. GStreamer has really picked up a good head of steam. It's being used in a lot of TVs, and actually Google TV uses it, at least Sony's implementation, which is interesting because Android does have its own media layer, Stagefright, which is replacing OpenCore. The interesting thing in multimedia in terms of open source is what I'd refer to as the codec wars. So a lot of these, so there's WebM VPA, which was a free codec by Google, and this is integrated into HTML5, but there's still a lot of issues around getting open source technology and particularly patent-free or patent licensable, I don't know what the right term is, compatible with open source license. Anyway, what? Unencumbered, that's the word I'm looking for. Unencumbered codecs would be really great. So moving on to file systems. So UBIFS seems to be kind of the default flash file system for embedded Linux systems on raw flash, NAND flash. Still needs some boot time improvements. YAFFS2 is not in mainline yet, despite some funding by Self. LogFS, someone is using LogFS because I saw this on a mailing list somewhere. But what? Are there patches for 3.3? I thought it was abandoned because it hadn't been any activity for a long time. In fact, I was surprised when it actually got in. I don't remember which version of the kernel it got in. But maybe that will, get resurrected, and there'll be some good. In principle, there's some interesting ideas in there. AXFS. This is an XIP file system. Apparently, Sony's the only company working on XIP. So apparently, we're the only ones that care. But we'd like to see it mainline. The interesting thing with file systems is now Google is moving away from raw flash for their devices. And they're moving to ext4 for future Android devices. And so part of me is kind of sad to see a move away from raw flash because now you've got these proprietary algorithms that are inside the flash chips that are responsible for the performance of your storage. And that is actually pretty terrible because these MMC chips are not optimized for the ext4 file system, let me tell you. They're mostly optimized for FAT file systems and for serial workloads because the majority of these chips they're built with the intention that they'll go into video cameras and stuff where the data is laid down in a serial fashion. And so you put a block interface on top of that with, B-tree algorithms and all this stuff, and it just doesn't, performance-wise, it's just not that great.
Question, I mean, if it starts showing up in a lot of Android devices, wouldn't the hardware manufacturers then say, hey, maybe we should optimize for Android?
One would think.
Yeah. As a hardware vendor, I'd be like, hey, if I optimize for ext4 or whatever, ext3 or whatever, Android may pick me and then.
Yeah.
It can't be just one way. You have to optimize both ext4 and the eLinux. So if you just optimize one form,
yeah.
The other one unchanged, that's not going to be able to.
Yeah, you need the hardware and the software. There was a comment over here. Yeah, it's almost bill of materials issues rather than technical issues. Well, it defeats the purpose of buying a cheap off-the-shelf part, is when you start customizing it, right? So anyway, yeah. Anyway, there's a talk on this. Arnd gave one. You can look up the video for this at ELC Europe, but there's a talk later. No, not today, tomorrow, on performance on eMMC. So, and this is something I think that there's enough people interested in it, I think people are going to start working on it, which again is not to discourage you from working on it. So, power management. Oh man, I'm, as I always do in this talk, I always get behind on my time. So, I may start talking even faster. Runtime power management, relatively new ability to suspend and resume individual system components. Magnus Dom had some slides on this last year's ELC. There's device power domains, a new set of devices. Well, it's a new capability for sets of devices sharing power resources, and Raphael gave a good talk on this at LinuxCon Japan and ELC Europe. Very, very recent. I mean, this thread is still alive on the kernel mailing list. This is a WakeLock compatible solution by Raphael called Auto Sleep and Wake Locks. I love the heck out of this quote. This series tests the theory that the easiest way to sell a once rejected feature is to advertise it under a different name. This appears to be generating well, it's early in the discussion, so it's too early to tell if it'll flame up. But it appears to be generating a less heated discussion than normal for a WakeLocks thread on LKML. So we'll see. And so we'll keep plugging away at this. I'm confident that someday Android will be using a mainline power management technique. Well, they already are using a lot of mainline power techniques. This is kind of the last holdout, and they, it's working for them. So, but there's lots that can be integrated there. So, system size, moving along rapidly. CE Workgroup has revived the Linux Tiny project. Bloatwatch. I don't know if you've ever seen Bloatwatch. There's a kind of a tool that's running out there that records the size increase of every kernel. Just for amusement's sake, pretty much, because I don't think anybody's looking at it and actively trying to prevent the kernel from getting larger. There's something called PokeTiny that was a Yocto project by Darren Hart. I think it was referred to as MetaTiny by Saul just recently. But that was described at ELC Europe. So there are still efforts to produce really low footprint systems. And again, it's not so much the kernel. Modern systems usually, although I would love to see a kernel, running in 2 meg of RAM with like a 512 meg text image for the kernel, 512K, I mean. But that's not realistically. Your big problem area is in the application space, and so things like killers. And avoidance, out-of-memory avoidance, are pretty critical. That's where the system can help out overall. So Android has its own low-memory killer. The one key thing about Android that I think is worth mentioning is that their application lifecycle really lends itself well to managing the memory on the system. And it's a very nice aspect of what they've done. Overall observations just on these technology areas. It seems to me that the rate of overall general features for embedded seems kind of low. We don't see a lot of core things. Maybe I'm just not counting stuff as core that I should be. But we don't see Bootup Time reduction patches a lot. We don't see size reduction patches. We have seen some security issues come up in embedded. A lot of problems in those areas have shifted to user space. There's not as much pressure. When you got a 50 meg user space, who cares if you got a 2 or 3 meg kernel? But there are some really hot areas in the kernel. So you got power management, you've got the ARM board support refactoring, you've got this GPU management stuff. And as always, we're always seeking ways to facilitate participation of embedded developers in the community. So let me go a quick rundown kind of along these lines with some of the CE Workgroup projects that are going on. So this is our contract work in 2010. You can look at it real quick. Two, I want to kind of highlight our YAFFS2 mainline effort and the trace format standard. So YAFFS2 is a popular NAND flash file system, was used in Android. It's still being used in a lot of embedded devices. And 3 mainline attempts were made, but we really hit some barriers there. The last actual status that I got on this was back in April or May, and it was stuck on some locking issues. So the outlook for mainline acceptance is kind of low. This is a classic case of a developer, the people who wrote YAFFS, wanting to retain multi-platform support. So the YAFFS code base actually supports other operating systems besides Linux, and so, as the developer of that, and it makes sense for them to want to keep some of that multi-platform support in the code base. And there were if-defs and things. But that approach is not really well received by the community. They're really looking for Linux-specific code sets. And so that was kind of the barrier there. The trace format standard. This is an effort to create a single trace format standard for the embedded industry. This was done by the LTTNG guy, Matthew. The idea is that this would allow reuse of tools with data from different tracing systems. It remains to be seen if that will happen. So what we have now, what got written, was a Babel trace conversion library that can convert trace formats into this standard format and possibly back. And there's a proof of concept conversion implementation. The idea is that if you can create some tools that utilize this format and then write converters for the different trace formats, we don't need to have kind of a grand unification of all tracing. We can still get the benefits of some slick tools and Eclipse and standalone tools. But it remains to be seen whether that will pan out. So in 2011, we did all this stuff. And I'm going to go over this kind of quick. Some of these I already talked about, like mainlining the fast symbol resolution. So that binary search lookup for module symbols, that was something the CE Workgroup paid for. We also we're working on mainlining something called device firmware upgrade, support into U-boot and into the Linux kernel. And DFU, if you've done Android, then you know what fastboot is. Fastboot is the name of both a utility and a protocol for getting flash images into the flash of a device without having to have the kernel running. And so it's very nice to be able to do that type of thing. And so there are already standardized tools for Windows and Linux and other host operating systems for doing these DFU operations to flash devices. And so if we could get that support in U-boot, one of the most popular bootloaders, and into Linux, then we could have a standardized way of manipulating flash images on our devices, whether they're Android or not. And so that would be pretty cool. So a lot of work was done on that this year. We also revived the Linux Tiny project. The last thing that was going on with that was they were working on function sections for the kernel, which is a way of eliminating dead code sections and dead data sections in the kernel for some size gains. Another thing that we did was we paid a contractor to work on improving UBIFS mount time. UBI, it turned out, or UBIFS had this really terrible operation, bad block scanning operation it did at mount time that scaled linearly with the size of flash. And so as flash got really big, you were talking about seconds of time to do a mount. And obviously that's not going to cut it when you want to boot the whole system in under a second. We were supposed to see some patches this week. I had my eye on the kernel mailing list, but I didn't see it, so be looking for that. That hopefully will show up. And then also we did a lot of flash file system testing. Out on the eLinux wiki, there's all these charts and graphs that show you different flash file systems, what their performance characteristics are. So you can go out and look at that, use that to evaluate what you might want to use in your products. We mainlined the Watchdog framework that I talked about previously. Should be a nice, easier way, kind of a more uniform way of add watchdogging to drivers. Also, we did some extensions to the Bluetooth stack, and this has to do with telephony and being able to have, like, for example, your car communicate with the SIM chip in your phone, and so be able to make voice-activated telephone calls from your car using your existing phone, which is kind of interesting. It's kind of a niche feature, but this is code that was already all upstreamed in BlueZ and the kernel. And then we have some projects that were not really under the category of contract work. So we had an Android mainline project, which you probably may have heard about, the long-term support initiative, and I'm going to talk a little bit about our open project proposals for 2012. So Android mainline project, the basic idea of the project is to reduce the delta between the Android kernel and mainline. There'll always be something that Google is working on that's not suitable to put in mainline. So the delta was never going to be 0. But if we can cut it down, and in particular, one of the goals of this project is to be able to boot Android open source project, be able to take Android open source project, build it, and run it on top of a mainline kernel. And I saw the coolest demo at Linaro last week. I actually saw that happen. It was a 3.3 RC3 kernel with about 12 lines of patches, and it booted up a stock Android system. So it was not accelerated. It did not have the network security stuff in there. But just that gives people a lot of opportunity to play with the system. And that's like a really good milestone to get to, in my opinion, as an industry. So there's a lot of work left remaining. We had some good discussions last week at Linaro Connect. There's a lot of people involved in this effort. And so as much as I would like to have the CE Workgroup take credit for this, Linaro has done an awful lot of work. A lot of community people have done a lot of work. And I think that's really a great thing. The long-term support kernel for the industry. So CE Workgroup has been initiating a new project, and I actually have some slides on this, but I'm going to go through them super fast because there's actually a presentation you can go to that's either the next session or the session after on the LTSI. And the basic idea is that we're trying to build an industry tree that multiple companies can collaborate on over an extended period of time. And as well as help companies take code that normally ends up just bit rotting on an FTP site somewhere and help create a path for that to get up to mainline. And here's some pictures of it. Oh, I'll go back. There's a picture of it. Okay. You can, if you have questions, come to Shibata-san's presentation. He'll tell you all about it. So we should have the first release. We're shooting for a June release. The Git tree actually opened up this week, and so that's good. The other thing I want to talk about, open project proposals. So every year, the CE Workgroup has this open, this period where we ask for proposals for work that we should do. So as companies, we kind of talk amongst ourselves and say, well, what kind of things would help to advance embedded Linux for the most number of people? So I've actually put together a web page or a wiki page, and I just did, if you go look at the history of this, this is like an hour ago I got this page up. So if there's mistakes on it, let me know. So for the next couple months, if you have an idea for a project that you think would be valuable for someone to work on to enhance embedded Linux, and you don't have the time, resources, or inclination to work on it yourself, you might be able to convince us to take our hard-earned money and spend it and do it for you. So you never know. Anyway, we're a little bit delayed this year. Normally we try to get this done in April, but for various reasons we probably won't be deciding the project until June. So some other stuff really quickly. It looks like a lot of stuff, but I'm going to go fast. In the area of tools, almost everybody now is using QEMU for stuff. You see it in Yocto and Android, and I even saw this crazy JavaScript QEMU implementation. Did anybody see that? You can run QEMU in JavaScript in a web page and boot the kernel. That is just too crazy. So Eclipse is now kind of a de facto umbrella tool for these kind of graphical development tools. So we're seeing a lot of Sony, in its infinite wisdom, decided to make me an Eclipse developer over the summer. Luckily, they saw the error of their ways, and now I'm back on the kernel. There's a special place reserved for people who can deal with Java and the Eclipse API. And I don't know, so, you know, I actually started, when I was doing this, I was working with Eclipse, and it's like, hey, it like tells you like the arguments to your functions. That is like really cool. But I'm still back on the command line, so I don't know. I don't know if we'll ever pry kernel developers away from their command line tools, but there are some kind of neat features there. And then in tracing, we're seeing a lot of activity still, perf, ftrace, LTT, and G 2.0, common trace format standard. And there's lots of stuff going on with tracing. It seems to continue to improve all the time, and it seems like there's a lot of new features that are really cool. And in fact, I didn't get this in there, but there's a presentation. Look in the schedule, a presentation on how to use ftrace to find issues in your embedded projects. So that's really cool. Build systems, Yocto is kind of this umbrella project, not just a builder. It has Eclipse tools and other things. Open embedded in Yocto, there was, when the project initially started, there was some differences between the two. They're kind of getting healed up and integrated. There's been a whole lot of talks at ELC and ELC Europe, and including as part of this ELC. That said, there are still lots of custom embedded build systems out there. So if Yocto or Open Embedded is not your cup of tea, there's also a build root talk and at ELC, and there's other systems. So you really, it's kind of in the golden age of build systems for embedded Linux. Embedded distributions, there's Tizen. So MeeGo, I don't know if I would say MeeGo is no more, but it seems to be waning. And Tizen is what's replacing it. And it's interesting that Tizen has a different focus. It's really focused because of the Limo contributions to it on WAC technologies. It's wholesale application something technologies, but it's HTML5 focused. So it's about creating devices that have that are using HTML5 as their application platform, which is so. Anyway, it's so you know that's good stuff. WebOS has been open sourced. There's still no, in the industry, there's still no kind of standard embedded Linux distro. I don't know if you can have such a thing because the embedded just covers so much territory. Android, you know, is going big guns. It's continuing to go. Oh, source release this week. See, I should edit my slides better. That was released the week of ELC Europe. Ice cream sandwich, unifies the code base. Everybody was really worried for a couple of weeks there, or a couple months when the stuff to what was the one before that? Something wasn't released. Honeycomb, that's right, the H one. Honeycomb wasn't released, but ice cream sandwich makes it all better. Let's see. So this is my little chart of embedded Linux distributions. And so there's a lot of variety in the marketplace. And this is just put up here because this is the year we kind of tend to do retrospectives on what's going on with Linux. There's only one embedded distro on here that is for sure completely dead and gone. And that's the one I worked on, EmbedX. So I used to be at Lineo. And it's kind of very sad it's gone away. But all these others are still out there and being used and filling different niches in the marketplace. So, yeah, TimeSys is still around. So, well, not by that name, but anyway. Actually, Linux, okay, so you have to, TimeSys actually did, oh, yeah, there you go. Yeah. I
used to work for TimeSys.
Okay.
It's very much now about embedded Linux distribution and tools.
Right.
And of course, the services working on bringing up.
So, okay. Not the RT. So I should just take the RT off. See, if this shows up next conference with the RT still on, I apologize. Yeah, but it's anyway. But there's a wide variety, so there's a lot of choices. Maybe too many choices. Industry organizations, well, we know who they are and what they're doing. The events, Android Builder Summit and ELC Europe is coming up. Android Builder Summit was just yesterday. There should be a lot of great content online. And ELC Europe should be fun. It's in Spain this year. I don't know how much overlap there is, but fun events. Oh, and this I want to mention real quick. If you are not using Stack Overflow, you should be. Stack Overflow is really cool. It is, I used it a lot this year. And it's where Google developers hang out and answer questions about Android stuff. And you see a lot of Linux-related questions, but you're seeing a lot of embedded Linux questions and answers. If you're unfamiliar with this resource, then there's a really good YouTube. I highly recommend you watch the YouTube video. It's one of these Google Tech Talks about Stack Overflow. And it's just a really great source of information. One of the key things I do all the time, I kid you not, is if you don't use the site colon search term in Google, you should. But I do site colon stackoverflow.com and then whatever my question is, and a lot of the time I find the information I need. And so it's a good site. The eLinux Wiki is also a really good site for getting lots of information. And so there's hundreds of pages covering lots of different topics. It's as with a lot of wikis, it's got kind of uneven quality level throughout. So you might find an area that's got kind of stale information. But there's a lot of good information still applicable in all kinds of different areas for embedded Linux. And make sure that you use that resource. And if you have things that you want to contribute, feel free to go up there and do that. So resources. Where do I get my information from? LWN.net. I'm just a shameless rip-off artist when it comes to LWN.net. If you're not subscribed, you should be. I get a lot of stuff about the kernel releases comes from Kernel Newbies. Someone is doing, I don't know who it is, but someone's doing a really great job there keeping information up to date. eLinux Wiki, and then there's the embedded Linux mailing list, which is a little bit quiet these days, but we should use that more often. Anyway, that's the status as I see it, so thanks for your time. And I was just given a 2-minute warning, which means we maybe have time for 1 or 2 questions if there's anything. Oh, I have stunned you all. Okay, thanks a lot.